Hey guys, today we're going to look at taking derivatives of logarithms. This section really comes in sort of two parts. The first part is just learning the rules for derivatives of logarithms. The second part involves using the log rules that you should have learned in pre-calculus to make certain derivatives easier to do. So let's start with this. This is the thing you need to memorize from this section. The derivative of natural log is just 1 over x. And if you put this together with the chain rule where you've got the natural log of some function, what you get is 1 over that function. And then by the chain rule, you have to multiply by the derivative. So you get 1 over f of x times f prime of x, which turns into this. So that's the part you definitely need to memorize from this section. Let's do a handful of examples. Some of these are going to be really quick. Find the derivative of y equals natural log of sine x. Well, let's see. Derivative of that is going to be 1 over sine x times the derivative of sine, which is cosine. So we get cosine x over sine x. So that's just cotan x. Now, in the future, I'm going to skip this step right here. I'm going to jump straight to writing the thing on bottom and its derivative on top. Well, let's see. This one, this example, we've got x cubed times natural log of x. So in this one, we've got to use the product rule. Y prime is going to be first times derivative of the second. Derivative of natural log x is 1 over x plus the second times derivative of the first. Now this first term we can cancel an x, and we're left with x squared plus, I'm going to write this as 3x squared ln x. That's the best way to write that, because that way there's no confusion about, if you write ln x 3x squared. If you don't put a dot here or parentheses or something, there might be some confusion about where the natural log ends. So it's good to put the 3x squared on the front there. All right, let's look at this one. We've got y equals natural log of x cubed sine x. So y prime is going to be, since it's natural log, we take x cubed sine x and put that downstairs. And then we put its derivative on top. Now when we do the derivative of that, we've got to use the product rule. So I'll do derivative of this is first times derivative of the second plus the second times the derivative of the first, 3x squared. I'm going to put it there in the front. Let's see, can we cancel anything? Well, the only thing that's common to both terms on top and on the bottom is x squared. So I'm going to cancel x squared. And so this becomes x cosine x plus 3 sine x over x sine x. All right, and one more. Find the derivative of this. Now this is another one where we have to use the product rule. This is my first function, cosine x, and natural log of x squared is my second function. So when I do this, I'm going to get first times derivative of the second. Now derivative of natural log of x squared is x squared on the bottom, and its derivative 2x on top. So that's first times derivative of the second. And the second is natural log of x squared. And derivative of the first, derivative of cosine, is negative sine. And the only thing I can really do to clean this up is cancel an x there. So let's see. I'm going to put that on the front too. So this will be 2 cosine x over x. Actually, I'll put 2 cosine x on the top and put the x in the bottom. And then minus natural log x squared sine x. All right. Now, I do want to talk about derivatives of other logs. If you have a different logarithm that's not a natural log, this is the formula for it. Derivative of log base b of x is 1 over x natural log b. And if we incorporate the chain rule with it, we get f of x on bottom, f prime of x on bottom, or on top, and ln of b also on the bottom there. Notice, if you apply this rule to the natural log, take the derivative of, the natural log is log base e of x. What you get out of that is 1 over x times ln e. And of course, ln e is 1. So this is completely consistent with the other rule. The other rule is a special case of this one. So let's do just one example here. Let's see, derivative of this, y prime is going to be, just like before, this goes downstairs. Its derivative goes on top. And the only additional thing is we have to multiply the bottom by natural log of 2, because that's the base. All right,